All right, day 2 of chain rule, and as one of the students just pointed out, it really should say 3-6 day 2 instead of 3-5. This is kind of the older sheet of notes, but it fits in a slightly different spot in this newer textbook, and so that's why we have that. Hopefully you can see that chain rule could actually be used on this one. We could do chain rule inside of quotient rule, or chain rule inside of product rule. And I believe probably inside of product rule is the better bet. And so, well, I don't know if it's way more fun, but it's going to possibly be less work in the end. So the first thing, I'm just putting in equals here. So you notice that really I'm not going to be doing the derivative yet. I'm just rewriting the original. And so that it becomes, the chain rule is basically when I write it that way. But we have to make sure that you understand how that's actually the same thing. What I did is I made that cube root unhappy by moving it to the numerator. And the 1/3 power actually does mean cube root, correct? Okay. So here we go. Derivative of the left side is f prime of x. So now if we're going to do product rule, we basically have, this is kind of the first part, and that's the second part. Okay. So for product rule, normally what we do is we write down the first one times the derivative of the second, and normally seeing I know chain rule is coming, and so what I'm going to do is I'm actually going to put a bracket there because I know it's going to take some space. So now we're saying this is the second term, so let's take the derivative of that, which we have to do via chain rule. So the negative 1/3 out front, then it's x squared plus 4, because this is like that g of x that got stuck inside that other function, right? Now, very easy to forget this. A lot of people do this. They go to the next spot, they write the 2x for the derivative of the inside, but something is obviously, well, hopefully obviously missing. Yeah, I have to take this down a power. Okay. And so it's negative 1/3 down another power is negative 4/3. Right? So is that basically the end of the chain rule for that one? So am I done then with this overall derivative? No. I've done first one times the derivative of the second one, right? So now plus second one times the derivative of the first one, which I was fairly nice and made the first one just x, so the derivative is just 1. Now here's where you have to decide how you would like to finish this problem. There is 2 ways. One of the ways is to write them as fractions and then get a common denominator and clean it up. Okay. Would you choose to do it that way? Or what we can do is we can factor out what they have in common. Okay. I believe that the factoring out, personally, I think it's quicker if we're trying to get to the simplified version of this answer. Okay. If you need me to show it to you another way, just stop in some other time. So now what we have to figure out is, well, let's just do like a little sidebar over here. If I had x plus 1 to the third in one term, and then I had an x plus 1 squared in another term, what can I actually factor out of both terms? X plus 1, so the smaller of the two, correct? So now as you look at this one, we have an x squared plus 4 to the negative 4/3, and an x squared plus 4 to the negative 1/3. And do agree that if we do chain rule inside of product rule, this kind of thing's going to happen a lot. And so we better get used to how to deal with that. So which of the two is smaller, the negative 1/3 exponent or the negative 4/3 exponent? The negative 4/3, believe it or not, is the smaller of the two. What's the difference between the two, negative 4/3 and negative 1/3? Is a difference of 1. Okay, so let's go back to this little, so it's x plus 1, what did I have here, the third? Plus x plus 1 squared. If I were to factor that out, this would just become to the first power, right? Why is that? Because the difference between the 3 and the 2 is 1, right? So that would just come to the first power, and then plus this 1 right here, right? From factoring it out front. And so we're going to do the very same thing here, but it's going to look, to some people, to some people it looks a lot different. So let's factor it out. Once you get used to it, it's a lot faster. So we know we at least have an x squared plus 4 to the, which one again is smaller? Negative 4/3 is smaller. And really, there's not much left over here, is there? Once we're done, there's not much left on this right-hand side, this right-hand term. So here we go. We're going to write down, now we're factoring it out of both terms. So what we have to do now is write down what's still there. Yes, we have a question. Okay, the question is what happened to the x in front? And we're going to get to that in just a second, because what I'm really doing is I'm just factoring this out of both terms. And in this bracket here, I'm going to write what would remain if I took that out of both terms. Because both terms have at least this. And so I'm pulling it out. Okay. So what would remain? Is that x right here, is it still there? Yep. Is this negative 1/3 still hanging around? Yeah. Is this 2x still hanging around? It is. All of that stuff still hanging around. And if I can multiply it together, it really becomes negative, what? 2/3 x squared, right? Now what some people do is they like to clean this up first and then factor stuff out, but I kind of like to combine terms. I think I'm at that level that I can do that, combine the terms and factor at the same time. Okay. So do you agree if I took this times that, it would be the same thing as what I had originally? Right? So now plus, now here's where people get confused. What's the difference between these exponents? The difference is 1. So if I factor it out, it's going to become x squared plus 4 to the first, because it's a difference of 1. Just like we had here earlier with the x plus 1 cubed and the x plus 1 squared, they had a difference of 1 between them, correct? So if I'm really just dividing by it's really what's happening, right? I'm dividing by that negative 4/3, so I'm really subtracting. Okay? If you want to look at it, and you end up with 1. So then basically, if I took this times that, so everybody want maybe look up here, this might help. If I take this one times that one, I do actually end up with this. Because I would add exponents, right? Negative 4/3 plus 1 is negative 1/3, right? So I would actually get to the power I actually had. Okay? Now I'm going to stop right now and make sure that everybody's with me on this. Everybody okay or no? Because when the negative exponents start popping in there, this is when this gets harder. If it was just to the third and to the second, I think we're good, right? But now that we got some negative exponents coming in here, it gets a little harder. So do we have any questions right now? Well, I'm just stopping for a second to make sure that we're all good at this step, because we just have a little bit to clean up. Yes? Okay, the question was, what if it was a difference of 2? Then there would be an exponent of 2 there. But let's remind ourselves what we're doing. We're doing chain rule, which always is going to bring it down 1. So we're always going to have that difference of 1 in these problems. Right? We just have to figure which one's smaller, right? But if it was a difference of 2, that's what we would do, right? We would square that x squared plus 4 there, because that's what the difference was, right?
The first x squared plus 4 was actually the difference of 1, and it's still this big x squared plus 4 earlier in the bracket.
Oh, okay. The question here is, what if the things got switched around? It still would be a difference of 1, exactly. Like if you chose to do the product rule the other way, you mean? Is that what yeah, it would still be, the smaller one would just actually be in the second half of it then, yeah. But it would still be a difference of 1. The other student was talking about something different. Yep. All right, so now let's clean this up. What do we got here? Well, that's to the first power now, so do I really need these parentheses? No, so what do we got here? We got negative 2/3 x squared plus x squared. It's really plus 1 x squared, right? So a positive 1/3 x squared is in here, right? Plus 4 times this out front. For right now, I'm pretty good for that with that. And if you want to go further, we could. We have a question? Yes.
Oh, okay, I see what we did. Okay.
Got it?
Yeah.
Okay. Yep. Could you give me a for instance? The question is about negatives, but I'm not sure. Oh, I think I get it. So you're saying like if there wasn't parentheses around the x squared or brackets around the other stuff? Okay. I'm taking all of this times that. All right. And here we know that we can get rid of these parentheses because it's to the first power. So now you could look at that as 1x squared minus 2/3 x squared if you wanted to. If that makes more sense to you. It would be fine to do it that way. Yep. Mm-hmm. But that negative 2/3 x squared is not getting multiplied by any of that other stuff in the brackets. Yep. And so if we were going to clean this up, let's find out what wants to be in the numerator and what doesn't. You know, or really you could leave it like that if you want. Is everybody good leaving it like that? Yeah? All right. Because I'm good leaving it like that. No, we can go a little bit further, but if we're going to go further, we're going to have to make this over 3 as well. So we would write that as 12 over 3, right? And so then what's really on the... Wow, there's a nice delay here. Right? On the bottom would really be the x squared plus 4 for the 4/3. Yeah, it's cool for you, but it's delay for me, so I can't even tell where I'm writing half the time. And then what else is on the bottom, though? The 3. Do you see how I had to get the 3 on both terms, though, to get it down there? And then it's x squared plus 12. More than likely, that's the answer, say, a textbook would have. Okay? Because they basically factored a 1/3 out of this term and got x squared plus 12 to remain. And so then they saw that the 3 would actually go on the bottom. But I had to get that for it to work out that way. But I don't think we'd have all that much trouble working with the stuff that's in green above that final answer there. Okay. Now I know some of you are saying, wow, that's a shortcut. Yeah, it is. It's much shorter than what we would have had to have done with the definition. We'd definitely still be working on the definition, which remember is the limit as delta x goes to 0 and all that fun stuff. All right, so now you might not realize that chain rule also works for trig. Because we normally just did sine of x, right, or cosine of x. So now it's kind of like sine of x, 2x has been thrown into sine of x. So there's your two functions, right? 2x is one of them, sine of x is the other one. So we can still do chain rule on this. Okay. Right, so the chain rule says to take the derivative of that kind of outside piece, right? So what is that outside piece? If our two functions, if f of x was sine of x and g of x was 2x, I'm taking this and putting it in there, correct? That's really what would happen to make this one that we have, right? So it says to take the derivative of that outside piece first, right? So what is the derivative of the sine? Yeah. Close. Just cosine. Yep, very good. And then what are we supposed to do with that g of x term that got stuck in there? What's that? Yeah, you just put it in there, write it down, right? And then what do we do with that g of x that we stuck in there? Take the derivative of it. So what's the derivative of that really angle, right? 2x is the angle, the derivative is 2. So the derivative here is 2 cosine of 2x. And it is still chain rule. It just doesn't look like it. Because we're used to chain rule being something to a power and using it that way. But this is still a function inside another function. Okay. And the only thing a textbook might do here is go back to those double angle formulas, because it is 2x, so it is a doubled angle, and maybe rewrite it that way, but that would be about all they would do. Any questions so far? Well, how about this one then? What would your two functions be? It's basically cosine of x and what was the other one that got stuck in there? X minus 1 kind of got stuck in there, right? So derivative of the left side, I'm really good at that. Equals, so now what? Yeah, derivative of cosine, right, is the opposite of sine. Where's the 1 coming from? Derivative of the inside, right? The derivative of x minus 1 is just 1. Oh, there we go. Right? There is a little opposite out front there, a little negative. Yeah. Okay, the question is, what if it was y equals 2 cosine of x minus 1? That 2 out front would just kind of be along for the ride. You could do product rule again, but then half the product rule, you're going to take times 0, right? And so then it's no good. Right? So now what I've done is I've given you 3 problems in a row here that almost look the same. They all have a cosine in it, they all have a 3 in it, they all have an x in it, and they all have a squared in it, correct? But I moved stuff around, so see if we could figure out, well, when do we use this rule? When do we use that rule? So we've got this one right here. I got to find the derivative of cosine of 3 times x squared. We could do product rule. It's a little more than what we have to do. Because when we take the derivative of cosine of 3, don't you agree cosine of 3 is just some number that my calculator knows? Okay, so when I take the derivative of that, it's going to be 0, right? So we can just use power rule, exactly, because this is just, it's a number, agreed? I don't happen to know it off the top of my head, but I do have a device that does know it, right? My calculator knows what that is. It's a number. So really, it's kind of like just the same thing as if I had 5x squared sitting there, and I would use power rule on that, right? So it would be, if you do the power rule, you put the 2 down, right? You got to multiply this 2 out front. And then you just write down cosine of 3 is what I would do. And then write x, and then you go down a power. Okay, sorry about that interruption there. I had a phone call about the 8th one I've had today. Okay. So this last one, basically, that cosine of 3 was just a number, so 2 times some number times x, right? Because if I take it down a power, it's just the first power, right? Is there any need to take the derivative of the inside and all that stuff? No, that's not chain rule, it's power rule, right? How about this one? So what's really being squared here? Can you tell? Okay, what's really being squared? 3x is what's being squared, right? So in other words, couldn't I just rewrite this thing as f of x, so cosine of 9x squared? Isn't that the same problem? That's what I started with. Do you agree with that? So, well, what we have here is kind of Trig's version of chain rule, right? Because I got that 9x squared that got stuck inside a cosine of x, right? And so here we go. Derivative of cosine then is opposite of sine. Now what? Yeah, it's that function that got stuck in there, which is the 9x squared, all right? So you write it down. Now what? Yeah, take the derivative of that function that happens to be the angle right now, right? Because it's what got stuck in there. And so what is that? Yeah, 18x. Now, is this 18x part of the angle? No, it's just something that got multiplied at the end, right? The only part of the angle is what I'm taking sine of, right? Which happens to be the 9x squared. So we can actually clean this up a little bit if we want. Then we would do what? Negative 18x times sine of 9x squared. There it is. But that's way different than the answer we got on the one before this. But that's because the parentheses were in different spots, right? Yes. The previous one? Okay, question on the previous one. Yes, this is, the question is, am I fine with an answer like this? And yes, I am, because having cosine of 3 sitting there is actually more accurate than someone going to the calculator and typing down the very weird decimal that would be. You'd have to round the decimal. And so that's exact. Okay? And plus, well, I guess it's radians, right? Because we know that there's no angle or degree on there, right? So I think that this would be much more exact that way. Yep. Back to the first one. Yeah, the question is, for this one, would 2x and then times the cosine of 3 be the same thing? And it would, but normally we like to put any numerals in front of the variable if we can. But yeah, because the multiplication there is commutative, so it'd be fine. Just not customary. All right, now let's see if you remember what this really means. Because I think rewriting this actually helps a little bit. This one's a doozy. It really means, and we're just lazy and we don't write it this way. That's really what it means, correct? That's how you would do this problem. You would find cosine of 3x, and then you would take that answer and square it, right? And so that's really what it's saying. So this, believe it or not, this I believe is the first time this has happened. Chain rule inside of chain rule. Because we really have like an x squared somewhere that cosine of 3x got stuck into, and that 3x got stuck into cosine of x. So two things, it's like a bunch of things got stuck inside all sorts of things. All right. So here we go, chain rule inside a chain rule. What we're going to do is we're going to start with this is 2 here. We're going to take care of that. We're going to take that 2 out front of everything, right? And now what? Well, that cosine of 3x kind of got stuck into x squared at some point, right? And so what we're going to do is write down that whole cosine of 3x. Because that got stuck into something. And now we got to take that down a power. It was second power, so now it's a first power. You with me on that? Okay, any questions so far? Now I have to take the derivative of that function that got stuck inside there, which is cosine of 3x. But to do that, if that was the only problem I gave you, cosine of 3x, and said take derivative, to do that you'd have to use chain rule, right? So here we go. We would take then, if that was the only problem I gave you, was to take just the derivative of cosine of 3x, not squared, you would do the opposite of cosine, which is negative sine. Then you would write down that 3x that got stuck in there, right? And then you would take the derivative of that thing that got stuck in there, which in this case is the 3x. And so there'd be this extra 3 hanging out in there, right? So can you see the chain rule inside a chain? Do you see where it happened? Kind of? Told you this was a doozy. Yeah, that's probably a pretty good answer, unfortunately. All right. So now this might help answer that subtraction question somebody had before. Am I taking cosine of 3x minus sine of 3x? No, those are actually multiplied together, right? There's kind of an understood -1 that's all getting multiplied there, right? So what's really, what can I put out front of this? I got a 2, I got a -1, and I got a 3 at the end. So do you agree I can put a -6 out front of all this stuff? Right? And then we got a cosine of 3x and a sine. Nope, the opposite got thrown out front. Yep. There it is. Please do not get lost in all these shortcuts that we're learning. That this is now a general equation that if you give me any x value that was on the original function, if I substitute it into here, what do I get as a result? A slope or instantaneous rate of change on that original at that x value. Okay, please do not lose that knowledge as we do all these shortcuts. It's very easy to do. Okay, and that's pretty much our last shortcut. And that, that's about as hard as they can get is this quotient and chain together, or chain and product together, or chain inside chain. That's about as hard as they can get. But again, think of doing that one by the definition. You'd have an x plus delta x in your angle that you'd somehow have to get out. And I don't foresee that being very easy. Okay, you would think it would be easy because this doesn't look that big, right? Okay. But it would be difficult. So what do we got? Our shortcuts are product, quotient, power, chain. There they are. And can they be used in concert, meaning together? Yes, they can. Okay. Okay. The cosine squared of 3x graph or the derivative graph? Yeah, somebody was saying that the graph was kind of funky, and yeah, it is kind of weird. Yep. Oh, you might be in, you want to be in radians when you graph trig. But it is still kind of a weird graph, but yeah.
Oh yeah, it's